Assalamu alaikum wa rahmatullahi wa barakatuh. Peace be upon you all and welcome to the channel. In this video we will cover the methods of the array list. Not necessarily all of the methods for the array list, but at least the important ones that either you will see often or you will use often. But before we begin, Bismillah ar-Rahman ar-Rahim, Alhamdulillahi Rabbil Alameen, Wassalatu wassalamu ala ashraf al-anbiya'i wal-mursaleen, Sayyiduna Muhammad, wa ala alihi wa sahbihi wa man tabi'ahum bi ihsanin ila yawmiddin, warda Allahumma anna ma'ahum ajma'in, Allahumma amin. اللهم صل على محمد وعلى آل محمد كما صليت على إبراهيم وعلى آل إبراهيم وبارك على محمد وعلى آل محمد كما باركت على إبراهيم وعلى آل إبراهيم في العالمين إنك حميد مجيد. We begin in the name of Allah, the most merciful in this life and in the hereafter, and we thank Him for all of His blessings that He has bestowed upon us, for they are innumerable. And we pray that we follow in the footsteps of Prophet Muhammad, peace be upon him, and his fellow companions. Amen. We also ask for prayers and blessings to be bestowed upon Prophet Muhammad, peace be upon him, and his family, as they were bestowed upon Prophet Ibrahim, peace be upon him, and his family. Okay, so as you know, I am a student myself of computational programming. So I am unaware of the entirety of the array list members. But the easiest manner by which you can check that is to simply check the source. Okay, so I probably need to create an object then, and perhaps I can check it. Alt and enter, not shift and enter. So I discovered another macro. If you wish to access it, instead of heading towards source like so, press and hold control and then one left mouse click and it will take you to the source. And you can check the different members, whether they are fields or, okay, that is a constructor, not a method. I want a stupid method. Yeah, there we go. Or a method. And of course, they have the documentation here. In programming, documentation refers to the delineation of the different members of a class, or even the purpose of the class, like so. Similarly, if you are familiar with research, especially in biological sciences, you have to document everything, including the results of your research, the methodology performed, the references or the citations used as reference for the experiments, and so on and so forth. In programming, you also have documentation, mainly because I feel that programmers cannot concoct I guess you could say clear nomenclature, sometimes, not all the time, to be fair. But from my experience, for example, this does not inform me even though it is a keyword, it does not inform me of the nature of the keyword. Final and private, yeah, sure, I can, if I am unfamiliar with the programmatic field, I can infer or deduce certain conclusions from these two terms. Private, so this is probably inaccessible, or it is private to this class. And final, this probably cannot be changed, maybe. Size, this is understandable. But transient, for a person with a pharmaceutical background such as myself, I would think of TIA, transient ischemic attack, for cardiological diseases, just as an example. So I feel personally people could use nomenclature in a more efficient manner, so it is best to document, to explain everything profoundly. Sorry, I'll be right back. Apologies for that, I had to answer an important call. Okay, so we will cover this. Possibly I will leave this as the ultimate lecture, how to create Java documentations, or perhaps earlier than that. We will see. I just want to finish this beginner level course as quickly as possible, because I may start this tutorial in Arabic, so create an Arabic version of this course. And then after I am done with that, either I will start with HTML or C. So we will see what will happen. A programmatic joke. Anyway, so you can read the details of a particular method or of a particular element through what is known as Java documentation. However, this is not how it will appear when you do create it. It will appear differently, but this is because these words or these paragraphs are part of the official Java API, so they have an appealing appearance to them. But what we will be creating is definitely it is completely different. And normally, as you have seen, the documentation precedes the element it speaks of. So this describes this. You may think that this describes this. No, it comes before, not after, because that is how the Java documentation compiler reads the information. So it must precede the member. It should not follow the member. Okay. So I myself am unfamiliar with all of the methods, as I have mentioned, so I will test them out with you. And I use the angle brackets to avoid the raw usage, as we have mentioned before. New array list, like so, and I will use integers for simplicity. Remember, you do not need to place it here. You need to place it here before the equal sign, not after the equal sign. This has been rendered redundant, thankfully. They should also program it so that you do not need to put these here as well, since they are already here, but perhaps in another update, we will see. Okay, so when I will just call this list instead of array. So remember, when we created an array, you would type in the name of the array, then the index at which you would like to place an element, and then you assign it an element, like so. This was the syntax for addition in arrays. But as you will see in a moment, array lists streamline the process ever so beautifully. So let us see what we have available in the for array lists. Okay, firstly we have size, and that returns an int, and it does not accept any arguments. So I can safely assume that this method presents or returns the size of the array list, the current size of the array list. Let us print it and see what happens. Now this has a return value, so if you display it like so, it will not accomplish anything. Remember, for return values, you must, or rather methods with return values, you must either store them in a variable or use them in a different method, such as the printing statement. Because a method with a return variable can be can be considered as a variable, because that return value becomes the value of that method. So you can think of it as a temporary variable. That is how I view it. That is my personal perspective. You can disagree with me. It is your prerogative. So let us print the size of this array. Oops. Let us print the size of this array to see what is the size. 0. Why is it 0? Because we did not add anything yet. This is an empty list. Similarly, if I create an array quickly, an array is equal to new int 5, and then I print the length of the array, array.length, it yields 5. Why? Because I designated it as 5. So remember, with arrays, those 5 elements are not empty, they are full, but with the null value, or 0. But because this is a dynamic array, or even it is much better than a dynamic array, because dynamic arrays are still static in nature. But because array lists are dynamic, the size only highlights the actual elements of an array list rather than the default null values occupying space in memory. Because at the moment we have not occupied any space in memory. We just have a pointer pointing to emptiness. But once we start adding values to the array list, that is when the array list will become, will actually have a size to it, or a volume to it, if you would like to think of it as such. So the array size, the size method is similar to the array name.length field. The only difference is length factors in the null values that are occupying memory, whereas size here only considers the elements when you have actually added the elements. Whether you create an empty array or a full array, the length will calculate the empty spots that are full of default or null values. So to calculate the array list size, you use the size method. We will print it again once we start adding values to it. Now remember, the size only factors in added elements. It does not factor empty space or nullable values. Does not factor in nullable elements. Okay, now let us actually start to add elements to the list. So let us return to the list of members here. Thankfully, we have add at the beginning, so this should be it. I do not think there are any add methods. Okay, yeah. We have add that accepts an integer as a parameter, as an argument, and returns a boolean. Or we have add that accepts an index and an integer element and returns void. Why integer? Am I unable to add anything else other than integer? Well, that is why generics are important for type safety, as we have mentioned, because I designated the type here as integer. So it only highlights integers because I cannot use other data types or other type parameters. Let us change this just to see if it will change in the list. List dot. There you go. So this is why generics are important for what is known as type safety. But I do not like strings, so I will use integers for simplicity, of course. List dot. Okay, let us test this and test this to see the differences. List add and I will add 5. Oops. I will add 5. Then we should print the list dot size. This should yield 1 because we have added only a single element. 1. Perfect. Let us check the definition of this function. Where is add? Add. As you can see, this is the type parameter. No, this is the void one. I want the Boolean one. There we go. You see, mod count. What is mod count? Let us check it. Oh, actually, I have to take this call. I will be right back. Apologies for that. I am back. Or I should say I have returned. So let us check what is this mod count. 111. Oh boy. Okay. Seriously? It is not defined elsewhere. Okay, let me try this again. Okay, so does that mean I have to go through every single one? Okay. No, this is ridiculous, man. I do not know where it is. It should. If it is purple, it should be. What is it? It should be a field or an instance variable. But I do not see it. It might be for another class. Yeah, it might be for another class, such as length, as you can see here. Where is length? I just saw length here a moment ago. Length. So this is an instance variable of an array immediately without thinking. So if mod count is not specified here, it must mean that it is a field or an instance variable of another class, such as length is an instance variable or a field of an array, element data, which we have seen here, element data. So mod count must be the same as this length. Otherwise, we would have seen it here if it was particular to array lists. Okay, so let us return to add. As you can see here, E is the data type, element data is the array, and size is the size of the array, and I'm certain it is this one right here. And as you can see, it returns true. So how were we able to successfully implement a functionality if this has a return value? As we know, normally methods with return values are stored in other variables or used in other methods. Well, this method has a functionality implemented into it, and it also has a return value. So even though a method has a return value, if it has a functionality implemented within it, it will still undertake that functionality or implement that functionality before it returns the value, its value. So this is irrespective of this because this has been accomplished regardless. So if I want to actually print the return value here, let us see what happens when I print it. Add 5, like so. You see it prints its return value, true. But it managed to, and here it printed size 2 because I added yet another value here, true. The reason it has a Boolean return type is to ensure that there was a value added here. just to ensure that it was added here. Okay, so we have successfully added a value. So Arraylist element addition. You use the add method. Okay, let us check the other add method. Actually, I will leave these in compilation. Let us see what the other add method does. This one here. Now this requires an index and requires an element. So let us say I wish to add the element I am about to add at index 0, and the second element will be, so I added 5 here. Let us add 6 for the pillars of Iman, or the pillars of faith. These are the pillars of Islam, these are the pillars of Iman, and this is the pillar of Ihsan. I cannot really translate Ihsan accurately into English, so I will just end it with Iman, which is faith. So what does this method accomplish? This adds your particular element of your choice, or the passed argument, at the specified index you want. Currently, this is the only element within the array, so it is technically the first element of the array, which means that the index here is equal to 0. However, I wish to shift this to the right and place it at index 1, and then place this at index 0. So I wish to insert this method, this element at this particular index. The reason I emphasize the term insert is because this is known as insertion normally, but here it is known as addition. At least for array lists, it matters not, because you still have the arguments that you need to, or the parameters that you need to pass as arguments. Now, if you return to the dynamic array lectures or subseries, particularly the creation lecture, you will see that we covered this for insertion and we covered this for addition. That is why I also emphasize the term insertion. So now this will become index 1 after this is achieved, of course, and this will be index 0. So element 6 will be index 0. So initially, the array list had this value like so, but now, after this, it will have 6 and then 5. So 5 will be pushed to the right, as you can see here, because it will have the first index, and 6 will have the 0th index, like so. So this is insertion, but it is under the name addition. It does not truly matter because it is technically considered addition too. So this is Arraylist Insertion, or addition at a specified index. I merely use the term insertion because that is what it is normally known as, and also because that is the term I used in the dynamic array subseries. Now let us print the size again. Now it should be 2. Perfect. We have 2. Why is it printing 1? Oh yeah, because I'm printing it here. So here it was 1, but after we added, it became 2. So I'll just remove this from compilation. There. So now we have 2 elements within the array. You know what? I will push this here and say calculates the size of an array list, like so, and then I will leave it like that. Yeah, that is more descriptive. Okay, what else do we have in the array list methods list? Okay, so we have equals here. it accepts an object and returns a Boolean. Okay, let us try it. Or actually, let us see first what it does. Equals. Why is this not alphabetized? Okay, fine. Equals. Aha, there we go. So equals here, as we have covered in the string class, it checks if the object passed is equal to this object, and remember this refers to the current instance of this current class here. So what does that mean is that if you wish to test and see if two array lists are equal, you use the equals method. So let us create another array list integer, and we will call this list2 is equal to new array list blah 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 blah. So I will add list2 dot add 5 and then list2 dot add 6. Now I wish to see if this list is the same as this list. It's probably because I did not use it. Yeah, never queried. Okay. So let us test and see if list1 is equal to list2 equals list2. And because this returns a Boolean, I have to print it to see if it is true or false. Okay. Now it returns false. Why? Because list2 has elements 5 and 6, whereas list has 6 and 5. Yes, the order matters, as we have mentioned in the first episode of array lists. Indexes or indices are incredibly important because they retrieve these elements, particularly if you have duplicate elements. And as we know, array lists cover, or rather accept, duplicate elements, as we have covered in the previous lecture. Well, what happens if I change the order? I add 6 here and then 5. Now let us test this again, and it is true. Why? Because they are in the same order and they have the same elements. 5, 6, and this, oh sorry, 5, 6, 5, and then 6, 5. So we covered array list comparison. So when you wish to compare two array lists together, we will not need this anymore because we do not need to compare other elements or other lists together. So I will remove this from compilation. I will just leave it here for reference for you. Okay, let us see what else we have. Clone is to copy, so we will not cover that yet, possibly in the near future, but this is to create a clone of your array list. Okay, here we have addAll, and they are similar to add in the sense that there is an index and then a collection, or just a collection. Let us check this to see if what else remains in these 3 dots. So let us add all here. So it only accepts a collection. Okay, and here you see collection of data type unknown, and it extends the type parameter that you decide upon. So this extends E. For this current program, E equates to integer here. So this informs the compiler that whatever the user passes here must extend what the user passed in E up above when we instantiated the array list. If I can reach the top. Come on, come on, come on. Oh, there we go. Sorry, I have to interrupt once more. I will be right back. Apologies for that. I have returned. So, as we were speaking earlier, E is the type parameter that we will pass once we instantiate the object. So E in this scenario, in this current scenario, is an integer. And addAll. This argument, or this parameter in this scenario, is of data type collection. The actual type parameter of that collection is still unknown because it depends on the user. However, it must extend or inherit the type parameter that we passed creating this list. So in this scenario, it is integer, and when integer extends itself, it normally means that the data type passed here will only be integer. If this was a number, if this was number, for example, and it was passed here, extends number, then this would can either be integer or float or double and so on and so forth. But when a subclass or a child class extends itself, that means it is only the child class that is allowed to be passed here. So this means that we can pass an entire collection as an argument to this method. Hence the term addAll. Add the entirety of the collection. And if we highlight and read here, or read it here, appends as in adds at the end of the current array list, appends all of the elements in the specified collection here to the end of this list, which is the one you create, obviously. addAll at a particular index is the same. However, you choose the specified position you wish to add that list, or collection, I should say. But since lists are a subclass of collection, and since array lists are a subclass of lists that are a subclass of collections, let us see if we can pass an array list as a collection. So I will return this to compilation. It turns out I do need it. Okay. So list dot array lists comparison. List dot add all, and let us add list 2. We do not have any errors. It is perfect. Now let us print the size of this array now. Oh, sorry. I forgot to use the proper syntax here. So I will remove this from compilation just so that we have only one size printed. So this should print 4. 1, 2, 3, 4, and the list. Well, actually, we still did not cover how to print an array list yet, or iterate through an array list yet. So let us leave that for now. 4, perfect. So we have successfully added an entirety of another list. So this list will appear like so: 6, 5, 6, 5. This is the first list, and this is list 2. Perfect. So we can call this array list. And okay, this is element addition, array list addition. So we are adding an entire list, evident by all. And we can have the same here. addAll at index 0, and C is for collection, add list 2 like so. So remember, array lists are a subclass of list, and list is a subclass of collection. Hence why you can pass literally any collection you want through the addAll method. It is not limited to just array lists. That is why the creators of the Java API designated collection, so that you can have flexibility. So this is Arraylist Insertion, and this is Arraylist Addition. Adding an entire collection. In this scenario, particular scenario, we are adding an array list. The same applies here, adding an entire collection at a specified index. So an array list at a particular index. But we do not need to add the list, so I do not think I will need these anymore, so I will remove them from compilation once more. Let us check what else we have. addAll, let us check clear and see what happens. List.clear, and then let us print the size, list.size. You probably have inferred from the name and the highlight here that it will say is always 0, that the clear method empties the array list. Array list, I should say array list emptying or deletion. Empties the entirety of the array list. So I should probably add adds an element at the end of the list, the array list. Because remember, addition normally refers to the addition of an element at the end of the list. Here, inserts element at a specified index into the array list. This, we can say, compares two array lists to see if they are equal. Because remember, you cannot say list is equal to list 2. This equalizes the pointer, not the object itself. So the internal value of the objects are not equalized with this, because these are objects, or rather this is a pointer to the actual object in memory. So here you are equalizing two pointers, not two objects. Whereas here you are equalizing or testing to see if two objects are equal, as we have seen in the string class before. I will remove this, there's no need for it. Adding an entire, add an entire, so I do not need this anymore. Okay. I do not need this because I actually need the list to be full for manipulation. Let us see what else we can use. Oh, contains and returns a boolean, so true or false. Most likely contains accepts a particular object to see if it is inside the array list or not, then returns true or false depending on the existence of that object within the array list. Let us check and see if the number 6 is in the list. It is, because we have added it here, but let us print the Boolean value to see if it is true or false. So remember, the list currently is 6, 5. True. So the 6 is indeed in the list. Let us check 7 and see if it is in the list. False. So this checks and sees if the element you have passed here is actually present in the array list or not. So we can say here array list element verification or presence, element presence verification. Checks if past element is present in the array list or not. So that is why it returns true or false. What else what we can use here? Ensure capacity for each, we will leave that for later. Hash code we have covered. Okay, let us test is empty, or let us sift through it in the alphabetical order. Or not alphabetical order, sorry, the order that is provided for us. Oh wait, it is alphabetical. Here it is not, unfortunately, but here it is alphabetical. So let us use get. What does get get? You pass a particular index and it gets or returns an integer. So let us see what happens. Currently the list is 6, 5. What is the element at index 0? 6. What is the element at index 1? 5. What is the element at index 0? So this should yield 6. And of course, because this returns a value, I need to print this value that I seek within the print statement. So what is the value or the element at index 0? Locate, then get it for me. 6. Okay. What is the element at index 1? This should be 5. Oops. 5. There we go. So, array list element retrieval at specified index. This is why I highlighted the importance of the index for array lists, because of such methods, and also for the add at index and so on and so forth. So this, and I forgot the y, retrieves the element at the specified index. So I do not need to print this anymore. Let us see what else we have. Hash code we have covered already, so we can skip that. IndexOf is the reciprocal of get. Here it accepts the index and returns the object, whereas here it accepts the object and returns its index. IndexOf 6. Again, the list is as such. I want to know the index of the number 6. So this should be, of course, 0, because it is the first element of the array. So it should be 0. Perfect. What about 5? What is the index of element 5? This, of course, is 1. There. If the array list only contains 2 elements, it is unnecessary, of course, to use such methods. However, this is incredibly useful if you have a large array list and So let us say you have 100 values here in front of you on the screen. It may be difficult for you to count from the beginning until you reach a specified index, so that is when you use such methods. But if you only have 2 or 3 elements, I am certain you can count that much. Oh, there's a sneeze. Do not leave me. Alhamdulillah. Oh. Oh man, that was a harsh one. Okay. So this, we can call it array list element index retrieval. Retrieval. Using a specified element. And remember, it said object here. Object because we are using a generic class, and generics always use reference data types. They never use primitive, except for certain scenarios where you need to use an index, of course. And this retrieves the index of a specified element, like so. And I do not need to print this. Let us see what else we can use. Okay, we have remove an object that returns true, so it is the same as add, except this is remove. So we can safely assume that remove removes the particular object. And this one removes the object at a given index. So let us test this. I wish to remove the number 5 or the element 5, and then I will print the size, list.size. So we only had 2 elements. This should print 1. Index out of bounds. Oh, so it calculates it as an index, but I do not want it as an index. I want it as an object. Okay. 1. Okay, so this will remove the element at index 1. Which is, so let me write the list for you again, 6, 5. So this is at index 1, so it will remove 5, and thus the size will shrink or decrement by 1, as you can see here. However, I am trying to remove an object, but it is reading it as an index. That is a problem. I want to remove the object, but it is always triggered as an index. Okay, I do not know how to switch it, to be quite honest. It should be able to detect that I want to remove a particular object, not the actual index. So this detects it. Am I able to trigger the IntelliSense as such, maybe? No, I thought I could. Integer equals 6. Yeah, I do not know how to trigger it. So let us leave this for now and cover this. Array list element removal or deletion at a specified index. And this, of course, removes or deletes an element of the array list at the specified index. So I will remove these two from compilation. Actually, I will remove this entirely. I do not really need it. But I still would like to know how to remove a particular object. It would simply, so if this was an array list of string, for example, it would not be easily confused. Array list string, I will call this list3, so I should probably put this beneath here, like so. Is equal to new array list. And then I can add here list3 is equal to let us add I for Islam. Okay, now let us try removing that. List3 dot remove I. Oh, sorry, I. And then list3 dot size. So this should yield 0 because we only have one element. There we go. Okay. So this is array list element removal or deletion, and this yeah, I'll just add it here. Removes or deletes the specified element, which is an object, of course. And I do not need this, and I do not need this anymore. So we have seen removal at a specified index or the removal of the object itself. Now, when you encounter this issue, you will have to adapt. So for example, since I am using an array list of integers, the compiler is confused between the integer object and the integer index. So if you are using an array list of integers, simply use remove with the index. However, if you are using objects other than numerical values, you can simply use the other overloaded method. And I do not need this, and I do not need this either. I may have to end this lecture and continue it on at another time because I have an appointment soon. Okay, let us see what we have. I may be able to finish this lecture soon. If not, I can divide it into two lectures. Let us see what else we have. So we covered hash code before. It simply prints the hash code of the object. IndexOf, sorry, so I managed to skip last index. Where is remove? It has been moved to the recently used ones. I believe I forgot is empty and lastIndexOf before I jumped to remove. I apologize for that. Let us test and see what this is empty method is. Actually, we can deduce that from here, Boolean, and is empty, so it is as if one is asking, is the array list empty? Yes or no, true or false. Now our array list is currently, it contains these two elements. So you can assume, or you can conclude the output of this statement here. This, of course, will yield false. It is not empty, it is full. We can test this later with removeAll to see this as true. So I will leave this here for now, and we'll say array list emptiness verification checks if an array list contains elements or if it is empty. Now let us see what else we have. And by the way, most of these methods I was introduced to just now. But once you have the knowledge and the source material or the fiduciary, you can easily identify or conclude or deduce the functionality of each method. To be quite honest, the only methods I was familiar with were remove, clear, and add. Those are the only ones I studied at my useless educational institute. Everything else I was introduced to during this lecture. But I was able to deduce the functionality of each method either by checking the parameter and the return value or simply reading the documentation here. It may appear daunting in the beginning, but believe me when I tell you this, because I have passed through the stages that you are passing through. Unless, of course, you are an expert watching these videos, then I still have to catch up to you, but I have passed through these stages. Forget what you read in books and forget what your professors teach you, because take it from me, they do not know how to teach. We can cover the definition of teaching later on, but because educational institutes consider education a privilege, not a right, thus you have what you have, unfortunately. But I do not want you to worry. It is, once you understand the basic concepts, it becomes incredibly simple. And all of this, of course, is because of Allah's blessings and well, I do not want to say convenience. I hate English. It is easier to speak it or say it in Arabic, but it is difficult to translate in English. If you put in the effort, Allah will bless that effort and create convenience for you. So you will find the process easy, streamlined, and smooth, provided that you put in the effort. If you do not put in the effort, do not expect a favorable outcome. That does not necessarily mean that whenever you put in the effort, you will always find a favorable outcome. That is impossible, because this life is nothing more than a test to see if you are worthy or not to enter heaven in the afterlife. So of course your patience will be tested to see if you are worthy or not. But when it comes to studies, if you put in the effort, you will find the outcome, bi'idhnillah, and God willing. Okay, so let us check what else do we have. lastIndexOf. You can infer what this is. Last index of the object, and it returns an int. So it returns an index of a current of the object that you pass. Let us test it. We need to print it in a print statement because it returns an integer. List last index of, just to remind you, we have 6 and 5 in that order. Let us say 6 and see what is printed. 0. So this is the same as indexOf. Last index. Oh, I do not know why the n was deleted. And what is 5? The index 1. So why is it different than indexOf? Last index. Let us read the documentation and see. And they do not have the documentation. Okay. Oh, okay. This is interesting. What was I looking at earlier then? I do not know. Anyways, okay. Returns the index of the last occurrence of the specified element. Remember, or take note of last occurrence. So what does that mean? It would mean that if your element was at a particular index and then you moved it to another index, lastIndexOf retrieves the previous index, not the new index. indexOf retrieves the current index, whether you changed its position or not. Whereas lastIndexOf retrieves the previous index if you have shifted the list or if you moved the element to a different index. So 6 was at 0 and it is still at 0, so this is the last index. 5 is still at 1, so the index here will be 1. Now if I switched 5 and 6 like so, the last index of 5 will still be 1, but the index of 5 here will be 0. So the lastIndexOf, remember, detects the last occurrence previously on Dragon Ball Z, but anyway. It detects the previous index if the index changes, of course. So here we can say Arraylist element element previous index retrieval retrieves the previous or last index of an element if it changed locations or indexes or indices, however you wish to create, however you wish to use the plural form. So we no longer need this anymore. Okay. List dot. What else do we have here? removeAll, and it is the same as removeAll previously, but since this is removal, it does not need an index because you are removing everything. We will cover predicates in the far future, not in the near future, unfortunately. I do not mean to delay this, but this is a beginner level. This is a more advanced topic, so I wish to leave it for later. I simply wish to establish a solid foundation for you to cover the fundamentals before you tackle the more advanced topics. If you do not understand collections or generics, you will not understand what a predicate is. So that is why. It is not that I wish to create suspense for you. Unless you are in my Dungeons and Dragons campaign, then you will be left suspenseful. Okay. I do not wish to refer to it as Dungeons and Dragons because I do not follow the lore nor the mechanics, because Dungeons and Dragons mechanically is stupid and narratively is convoluted and stupid. Anyway, just like Kingdom Hearts. Anyways, let us cover removeAll. And just as with addAll, we need to pass a list. Let us see if I can pass the list itself recursively and see what happens. So let us print the list and see if this will actually yield 0. Oh, sorry, this was 6 and 5. 0. So it has removed the entirety of the list. Let us see what this prints. It will print 2. So it was successful at removing an entire list. So I will remove this from compilation and I will remove this completely. So this is Arraylist removal or deletion. This deletes everything, deletes or removes the entirety of the specified array list. This of course accepts a collection, but I say array lists because we are manipulating array lists in this lecture. I may have time for one more method perhaps. Oh, I just remembered. Let us remove it, delete the entire list, then see if it is empty now. Is empty. Oh, sorry. List.isEmpty. Is the list empty? This should yield true now because it is empty. So I will leave these two together just to remind you that we used the removal, then we checked if it is empty or not. I do not know why this is underlined. Possible typo, you repeated the because of this. Okay, so you know what, I will just place it here then. Oh, it is still detecting it. Oh well, there's nothing I can do about that. Okay, we'll end the lecture here at removeAll, and then in the next lecture, bi'idhnillah and God willing, we will continue with list.toArray, because I just realized I do not have time, unfortunately, to continue with toArray, and we will continue other methods as well, bi'idhnillah and God willing. Then after that, we will also cover iteration. So how to iterate through an array list. We may cover the iterator class in that lecture, or I may leave it to later. It may possibly be later. We will see what happens. Bi'idhnillah and God willing. I hope this lecture was helpful and beneficial to you all. Enjoy the rest of your day, everyone. Be safe, take care, and peace be upon you all. Wassalamu alaikum wa rahmatullahi wa barakatuh. اللهم صل على محمد وعلى آل محمد كما صليت على إبراهيم وعلى آل إبراهيم وبارك على محمد وعلى آل محمد كما باركت على إبراهيم وعلى آل إبراهيم في العالمين إنك